try to draw some sort of a decent looking box or whatever. I know it may not look like this, but this and this. It doesn't have a top on it or anything, but if you if that box is 10 cubic feet, and of course that means that the values are in feet, is 10 cubic feet, and what they're asking you to do with it, write an expression for the area of that box in terms of x. In other words, write the area of that box as a function of x. How would you go about doing that? Write the area of that box as a function of x. Now remember, the box does not have a top on it. It's an open box. So
do you want regular area or do you want surface area?
what now?
You know, like the regular area or do you want the surface area?
Regular or surface area?
I don't know what is that? What's regular area versus surface area?
I don't know.
They're the same, right? Just surface area is whatever, just surface area. Anybody got it yet? It's a very simple problem. It's nothing complicated. Get it? Get it?
Is she right? Am I right? Nope. I think there was numbers to begin with, so.
Anybody else get it like this? It's a very simple problem now. Oh, y'all do? Y'all.
Yeah, see, like last week when he showed us this problem, we had some numbers to go with it, so it's gotta be that. So I'm probably wrong.
Yeah, you had to make that up. Hey. think you did.
By heart.
No way.
Okay, what, you know, you must be working.
It's just a mid-sized square.
Look, take the box apart.
Mid-sized square.
Yeah, but take the box apart. And then you got what? Then you don't have to find the area.
Yeah, so it's gotta be that,
Right? Huh? Well, they don't top on it. That's what I mean, you ain't gotta take loose. I mean, my God. That's what you get the leave out. That makes it easy when there's no top on it.
I know areas.
You don't have to pry the lid off. Take it apart.
And then his,
Take the box apart, you all. Take the box apart and lay it out in pieces. That's all you have to do. In other words, you know good and well. Look at this, everybody. This is the height of the box, right?
yes.
Remember, it doesn't have a top on it. So hell, this side right here, you know what the area of this is right here? It is x times h.
Yeah,
You know what it is right here to here?
X times H.
X times h. You know what it is on this side?
X times
X times h. You know what it is on the back side?
X times H.
X times h. Well, hell, there's 4 x times h's. 1, 2, 3, 4. And then you got what? The bottom. That is what? That is the area of that box. Now, dang it, that's not written in terms of what?
The function
Of x. It's written in terms of x and
H.
h. But guess what? I was good enough to give you some very important information. And what was that?
X and
It
H.
says that what? That x squared times h is equal to 10 cubic feet. I told you the volume was what? 10 cubic feet. Well, hell, this is easy to say that h is equal to 10 divided by what? X squared. Yes or no?
Yes.
Well, guess what? 4 times x, and you know what h is? 10 over what?
X squared.
Plus what? X squared. This is what? The surface area written in terms of x. You can multiply this out if you like. This becomes 40 over what? X plus what? That's the surface area with respect to x. That's so simple. You just had to take the box apart. Did that not make sense to everybody? Do you understand what that means to you? How many of you understand what it means?
Then you need to break the.
It means what?
You need to break
It means that a box this size, if you were given a box this size, and all you were told that it had a square bottom on it, okay? The bottom was square. And you were told that it holds 10 cubic feet of whatever, okay? Well, guess what? You would know exactly how much to go by, how big, how many square feet is the box, if it's what? All you have to know is the x value. You would know the surface area if you knew exactly what the bottom was. You just have to know one number, and you have all this information about this box. Just knowing what? There's a connection between the what? All these things. You've written it what? You've written the volume or the surface area in terms of what? What are the variables?
X and H.
You have to be able to do this. Listen, everybody. You cannot take, well, you can, but it's a very difficult process. If you have been given a calculus problem, and the fool thing is what? Is written in terms of 2 variables, and you being asked to take the what? The derivative of this thing? with respect to two variables instead of one? You understand what I'm saying? How easy it would be to work with just one variable versus what, two or three? Am I making sense of why you need to be able to write a function of something as a function of x or some value, some letter? Because take a look at this problem like this, okay? This is like this, okay? That's like a code, okay? Now let's think about this a second. When you start allowing water or some liquid to go into that ice cream cone, unlike this, for example, you see the difference between this? Now look, take a look at this thing over here. Take a look at just the cylinder. And if you're letting water go into the cylinder, folks, there's not but two things happening to that thing. And that is the volume is changing. And guess what else is changing?
The area.
I think the areas.
No, you're not looking at what I'm doing. You're just guessing. Hell, the height of the water is changing. Only two things is changing. The height and the volume on the cylinder. You see that? Now turn the water on the ice cream cone and tell me what's happening there. Turn the water on the ice cream cone. Tell me what's happening to that.
Filling up from the bottom first?
Damn it, it's getting what? More volume in it. That's pretty easy to think about, right? Get more volume. What else is happening? The height of the water is increasing. What else is happening?
The volume is increasing?
We've already said that. You weren't listening. What else is happening? David, what else is happening to my ice cream cone?
Melting?
Wake up. Y'all need to get some coffee beans, chocolate covered ones. Go eat some. Give you some lift. Go to Publix. Get them at Publix. The cheapest place to get them at Publix. Y'all don't get coffee beans?
I got some.
Y'all crazy. You need coffee beans. How you gonna do math without caffeine? Your body's nothing but a machine for turning caffeine into theorems. Yes, what?
So what would be?
No, that's not the right answer. No. Mr. Flower, go ahead, I'm sorry.
So if you were to ask us what the range was.
Yeah, well actually you're doing what? You're looking at this ice cream, different from the cylinder,
Yeah.
where there's only two things happening when you turn the water on, and the water level is rising, and the volume is getting bigger. If you did that same thing to this ice cream cone, not only is the volume getting bigger,
The surface
But
area
the-
is increasing.
but the what? The height of the water is rising, the radius of the water is changing, the diameter is changing, and the
Surface
circumference and the surface area of the water is. So there's a hell of a lot of stuff going on in one application of turning a spigot on. So you have to do what? You have to say, wait a minute, I can't deal with all these things going on and try to calculate what is the rate of change. If they're going to ask you things like this, what is the rate of change? If you know how much water is going into this container, if you know how much water is going into this container, folks, per minute or per hour or per day or whatever, you can go back and calculate exactly how fast the surface area is changing. Or you can calculate how fast the what? The radius is changing. You can calculate the circumference and how fast is changing. You can also calculate how fast is the height changing. Only knowing one thing about it, and that's how much water is going into the container. Drop, 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 drop. If you know that, does that not make sense to why you have to know how to write these equations in terms of one variable or two or whatever? It is best to write it in terms of one variable. Because all you have to do, if you think about this, you know what this makes? This makes nothing more than this. You see that? That's a three-dimensional looking picture, which we can do what? You can say this. This is little r, this is big R, right? Right? This is, guess what? Guess what are we going to call this? Big H. Wow, that's big H. You know what we're going to call this? How about little h? Does that not make sense? So if that is the case, then somebody's going to have to give you some of the numbers of some sort. You know what that makes up there, you all? How many of you know what this makes over on this side over here? A what? Somebody said it. A what?
Rectangle.
It don't make no rectangle. Yeah, I know. Where do you show me a rectangle? Now you put my glasses on.
Okay, I thought you meant.
Okay, you thought I meant. You know what I thought You see what I'm pointing at over here. What does this make?
A rectangle.
Piece of pizza?
A what?
Piece of
No, pizza, hey.
Oh,
Gee
a
whiz.
triangle.
Lord have mercy. It makes a what? A what?
Don't it make a triangle?
A what?
Triangle. Correct. That's what you pointed at right there.
No, it makes two triangles. It makes two triangles. You see there's two triangles up there, and when you look, they're similar triangles. You don't just tell me they're what? It's a triangle. Now that's what? That's that's a big triangle and a little triangle. You know what? And they're similar. You know why they're similar? Tell me why they're similar. What makes them similar?
They have the same angle.
What makes triangles similar?
The angle.
What it?
Right angles.
Angles.
Right angles.
Angles.
Right.
Damn, can you be more specific than that?
Right
Right
angles. Right
The-
angles.
The angles are the same. Don't you realize that this is a 90 right, that's a 90 right, that angle is the same as this angle? You know why? Because that's 90 right, and this angle is the same for the little bitty triangle as it is for the big one. So when that happens, you can do what? You can write this as a what? It's similar triangles. And it doesn't matter how you do this. You can write it as a ratio and proportion problem. Big R over little r is equal to what? Big H over what? Little h. Does everybody see that? Let's suppose this is 4. Let's make this what? 20. Okay? Let's make that 4 and 20. So if that is the case, then this would become 4, this would become R, this would become 20, this is this, right? So guess what? Watch what you can now do. Everybody take a look at this. I can cross multiply. You remember doing it? Y'all know how to do this. It says what? 4H equals what? 20R. Right? Everybody see that? So, now, I can solve this equation for H and say H is equal to 5R. Everybody see this? H is equal to 5R. Yes? Now we can go back and we can say, I'm going to erase this away, because this was sort of simple here. we can say the volume of this thing is pi r. Everybody see that? Now that's for what? That's for the small one, right? That's for the small one. Guess what h is? Guess what h is? So v is equal to what? Pi r squared times what? So this is equal to what? This is 5 pi r cubed over what? Do you see what that gives you? How many of you absolutely say, but Sister Rose, what does that give you? Don't look here.
I can't see it.
You can't see. Okay, you can't see the board? Slide over. Okay, you haven't been able to see the board the whole time?
No, just that
Yeah,
one
my
right in
gosh.
the corner.
Whoa.
I can't see it.
Somebody tell me what that says.
Volume equals surface.
Oh, hell, I can read.
Read it.
Come on, tell me what it says. I'll show you something else. Give me a second, I'll show you something else. And then maybe you'll see it. We have this problem right here. You see this? All right? See this, everybody? This can cancel, and that's what? 1/5. So now you can say that the volume is equal to pi r squared h divided by 3. Volume is equal to pi, and what is r? R is 1/5 h, that's what? That's 1/25 h times what? So this is volume is equal to pi h squared over what? 3 times 25, and which is pi h squared over what? 75. Do you see what that's telling you? That tells you this. If you know you have an ice cream cone of that shape and that size, all you have to know is, all you have to do, folks, is look at this. You just stick a stick down in here and you measure this height, and if you know how high this is, you know how where the volume comes up. Some of y'all not paying a damn bit of attention to what I'm saying, and you need to. If you know this height in this container, guess what you can do? You will then know the volume of it. Only just knowing what? How high the liquid is up on the stick. Does that not make sense? You see why they do these things? This one over here says what? You would know the volume if you just knew the radius of the little bitty container. You can calculate the volume of it. And only knowing that one value. And you can now come back and say, I'm writing this volume as a what? As a function of the radius. Everybody see this? Over here, you could say what? I'm writing this volume as a what? As a function of the height. How else can you possibly, listen to me carefully, how else can you possibly take and make use of calculus when calculus does things like this? It tells you the rate of change. It's a very easy rate of change stuff. And if you know something about the rate of change, it can give you what? It can tell you precisely, with respect to time, what that volume is changing. If somebody wanted to know how fast is the volume changing in that problem over there, you see that, everybody? If somebody wanted to know how rapidly is the volume changing, you just have to tell me over there, at what rate is the height changing? Just that simple. And you do something called, you calculate the first derivative. First derivative is a rate of change. The first derivative gives you what? Velocity. The second derivative gives you what? Acceleration, as we talked about the other day. The third derivative gives you what? The jerk. These things you have to know. Listen, you cannot study calculus unless you know how to take the algebraic equations and make them make sense to you. Make them work for you. Is that making it? No, I'm not making any sense. No? Does this make sense? Right here. You would know the volume of this ice cream cone if you only knew what? If somebody told you at this very second, look, let me tell you this, everybody. If the water's going in this thing continuously, I guarantee you the radius is changing continuously. So then you're going to have to say, what is the volume, how much is the volume changing at that very moment that you spoke about? A moment later is going to be what? Something different. Yes?
So rate of change is change in value over change in time, correct?
Right, yes, yes.
All right.
Right, that rate of change, yes. First derivative.
Yeah.
First derivative. It's the same as what? It's calculate the slopes of a linear equation. It's the change in the y values divided by the change in the x values. The same deal. Same deal. Same thing.
Isn't that how they solve like miles per gallon?
Is that?
Isn't that how they solve like miles per gallon? Like if you're like in a car and you put in 1 gallon of gas, and so that would be your vertical change. And your horizontal change would be your distance traveled.
Right, yeah.
50 miles, so you would go.
In other words, you're looking for this. See, how many
You're so close.
How many what? Miles per gallon. That's the rate of change. That is another rate of change problem. Miles per hour, feet per second is a rate of change. And here's the thing about it, folks. They're going to do this to you. They will actually put restrictions on you. They'll say, okay, you have, just for sake, let's say you have 160 feet of fencing material, okay? And that's all you have, yeah? It is your job to put up a rectangular garden. Now guess what they gotta do to you? They gotta put some restriction on you, because you know why? Because there's a barn on one side of the garden that you ain't gotta put a fence up. So that means you'd have to do what? The garden would look like this, or it could be a river, it could be, so the garden is gonna look like this, right? This is X and this is Y. Everybody see this? There's no fence here. So the perimeter is equal to what? 2x plus what? Plus y. We said we had 160 feet, right? Don't you remember the problem when I told you about the young man who was given 100 feet of fencing material? And he was told to go over to the back side of the property and put it up? You remember that? Y'all remember that problem I gave you? Some of you not, because you hadn't been in my class before. So the farmer gave the kid, he said, look, take this over to the back 40 and put this up. And he comes back a couple of days later and he says, oh, wow, you know, you got to come over and look because you taught me well. You taught me how to put the quarter post in cement. And I took the transit over there and I lined that fence up perfect and straight as an arrow. And we pulled the wire with the tractor and we got it just as tight as could be. He says, you got to come look at it, and he does. He gets in his truck, he drives over there, and hell, what did he find? The young man had done this. "48 feet long, 2 feet wide, poor damn cow can't even turn around." He used 100 feet of fence, right? How's the cow going to have to back up to eat grass, right? And what are you supposed to have said to him? You idiot! What were you thinking? And he said, well, sir, I looked over next door to the farm next door, and I sure didn't want to make the mistake that guy made. You know, he had 100 feet too, you know. He didn't put his all up one straight road. His won't hold a single thing. At least mine will hold a cow too. So the question comes up, how should he have put the fence up? Mr. Roberts, how would you have put the fence up? If you were given 100 feet of fence, say, go back over the back 40 and put it up. I don't think you would have put it up 2 feet wide and 48 feet long. I think you'd use a little bit more common sense in there, right? How would you put yours up?
It'll be wider.
It would be, oh, okay, well, now we're getting down to some thought processing here now.
Right.
So what would you do? How would you put it up? Because your job would be to do what? Try to cover the most ground, right?
25
He's over here talking something, mumbling something over here about 25 by 25. Yeah, I don't know what he's talking about. But that'd be what? That would be the ideal way, I guess, to put it up, would be what?
I think I just make a circle.
That'd be what? That'd be 25 by 25. He used 100 feet of fence. This guy right here has got 96 square feet of grazing space. This guy's got 0 square feet of grazing space. This is at least what? 625 square feet. You used the same amount of material and did what? And how did you do that? You did that by using calculus. You didn't know you did that, did you? Well, that's how it's done, is you use calculus to do this. But this is called common sense, right? Well, calculus is sort of common sense stuff, in a way. David, how should he, if that was your objective, how should he have put the fence up? If that was your, Mr. Roberts, if that was your objective, how would you have put the fence up?
What was my objective?
Is what?
If what was my objective?
To cover the most ground. Mr. Roberts, how would you put it up? Mr. Roberts, in a circle. I mean, how long have I got to hold my hands up to show you?
You were stretching.
Hell, I ain't stretching, I'm trying to show him, put it up in a circle.
You was trying to stop osteoporosis.
If that was your job, is to do what? Is to maximize the ground that you're covering with 100 feet of fence, you put it in a circle.
You can't make it a circle with it.
Yeah, what?
You can't make it a circle.
Yes, you can.
Not with fence posts, you can.
Don't tell anybody that.
Alright.
That's why they don't do it, is why. Because it's too difficult. And properties are not in what? Round circular patterns either. But you do, like I say, if that is your objective, you would do what? You would make it in a circle. There'd be other things that you would do what? You would say, okay, I can make it in, the fence post is too hard. If you've ever put up a fence, then you know. It's hard enough to put one up in a what? A rectangle. So, but if you had to do that, you put it up in a circle. If you put it in a circle, now how many square feet of grazing space you have now? Quickly. Y'all slacking off on the job. Hurry. Calculate that for me. Hurry. Don't be looking at it. Calculate it. You stretch it, don't look at it. It's a circle. It's a circle. Come on, hurry. Find the area of the circle.
What's the number?
I ain't gonna tell you that.
Area of the circle.
Look over here, David. What are you asking about? I saw you asking what you put it. Hurry, what'd you get?
It's higher square? No, they're not. They're round.
Where's tacky jack?
I got it. Pi r square. Was that not even close? Oh, like you wanted the area.
you actually figure it out now.
Oh.
Hurry up, you all. I don't have all day.
Do you want a written?
Pi r square.
I want to know how much area you got if you put it up in a circle, if you could.
So 195 feet?
Yeah.
Come on, give me a break.
Whatever that is.
Mr. Wilson.
That's right.
Hell, I got 625 square feet if I put it up in a square.
Or can you say 195?
How much?
795.
Okay, how'd you do that? I thought you said something else.
Oh,
Is that what you said to start with?
yeah, by the time.
They can go up there and do it.
Yeah,
I thought you said 100 something. You 700, how much?
95.
About 796, close to it.
96, round.
Everybody see how you got that? No, hell you don't, because you didn't do it.
He should have did it on the, make them do it on the board.
Right, get up there and do it on the board.
Get up there. I want to run on that board so bad.
I'm gonna keep it on.
The answer is what, about 796 square feet. Everybody got that? You get it? No, I wonder why not. Come on, folks, y'all do this problem. Look at that. The area of that circle is what? Is 5 times the radius squared.
Okay.
Right? Or you could write it this way. A is equal to, remember this, 0.7854 d squared. Yes or no?
I don't remember
And
that.
you know good well that 100 feet is equal to pi d. That's the circumference. D is equal to what? I'll make this a little d. D is equal to 100 divided by pi. So I go back over here and I put 0.7854 times 100 over pi squared, and that's it. 796. It's so simple. 796. So you go from 0 square feet, 96, to 796 square feet. Folks, you cannot take a string and make it in any other shape other than the circle to maximize the area that you enclose. That is maximum. That is an elementary program or problem in calculus that you have to show. That a circle is in fact the maximum area for an enclosed figure. Everybody see how we did this? No? over here, you only know the circumference is 100 feet, right?
Right,
Well, circumference is equal to pi d.
okay.
So if I divide 100 by pi, I get the diameter, right? Look at that equation over here. It says all you need is a diameter. Diameter squared, and then times what? Times pi. Times 0.7854. It's done. 796.
Okay, I multiplied.
Right here, take this right here and put,
This
take
is
your calculator,
what I
take
copied,
100.
But this is the way I was figuring it. Is area is pi r squared, right? So pi times the
No, that's not 50.
that's 100.
The 100 is circumference.
That's why I did.
That's why. The
Okay.
circumference is 100 feet.
Okay.
So the circumference is what? 2 pi r, right? 2 pi r?
Okay.
R pi d.
D.
That make sense? That make more sense?
Yes.
Did that make sense? Making sense to you? Not really? How can it not make sense, folks? It's too simple.
I understand that you can get the maximum speed from something by doing a
Circle.
I understand that part. But I'm not.
How you got there?
Yes.
Look, you just have to find the area of that circle, right?
Okay.
But the only thing you know about that circle is what? Circumference.
Okay.
You know how to find the circumference of a circle?
Isn't that what you-
How you get it? How you get the circumference of a circle? Pi d. Pi d. Pi times diameter. Well, now look, if you know the diameter,
Oh, pi d.
you see this right here? You see this equation right here? That's it. If I know the diameter of that circle, I can calculate the area with that equation. That make sense? Pretty simple? Easy? So if you got 100 equal to pi d, what is d? D is what? 100 divided by pi, right? What's 100 divided by 3.14? I don't know, don't care. So, but you do what? You square that and then multiply it times what? 0.7854, and you got 796 approximately square feet. Emily, which one is the cow gonna like best now?
In a circle.
No, the cow's not gonna want a circle. The cow wants this one over here, and you know it want to be pinned up. My Lord, why do you want to think he wants to be pinned up in something? He'll choose this one over here. Which one will the farmer choose? The circle. Okay, that's better. It's all in perspective, you all. You got, no, how many of y'all don't look at things in a perspective? The sinking of the Titanic was a miracle for the lobsters in the kitchen. Y'all stop laughing, that's true. I mean, am I right or wrong? So you have to look at it from the cow's point of view. Don't forget that. It's all in perspective. I forgot what I was doing now.
Talking about the Titanic or something.
Oh, yeah, I know. We done got off the Titanic. Oh, we're coming back over here. We put this garden up, right? What is this? Oh, this is not part of the garden. That's not part of it. This is the garden here. And you see what they did to you, everybody? They did what? This is a barn. There's some cows and stuff in there. But this is the fence that you're going to put up. So what did they do to you? They said, well, we're going to make this a little bit more complicated than putting up a regular fence. So you can pretty much easily figure out that what is rectangular. But, wait, I got to get all this stuff off. This is gone. Cow's gone. What about this? This is gone. This is not gone. Does everybody see that this 2x's plus 1y is all the fencing material you need? Because you don't need 2 y's, do you? Because why? Because the board is taking up one of them. Now what about the area of this thing? The area is equal to what? Length times width, right? Boy, that's not too good, is it? So you probably need to do this in terms of what? Only one variable. So we can come back and we can say 160 minus 2x equals to y. So the area now becomes what? X times y, and y is what? Who's paying attention? David, you was not. You were sleeping. No, I'm just kidding. He was really paying attention. Everybody paying attention? Do you see how to do this? This says what? That the A of x, that's the area written in terms of x, is equal to what? Did I do that arithmetic right? Some of you squished up your eyes like, I don't know.
Yeah.
Yeah or no?
Yeah. You did.
Don't just sit there, finish it. No? What is the maximum size garden you could make in a rectangle?
45-degree angle? No, let's try.
Hurry! I can't wait much longer. You all are taking up too much time.
Patience is a
You're killing me. But the flowers, hurry, you finished?
I mean, I was just gonna say that it'd be like, I mean, technically, if you're asking for how large the rectangular, like, area should be, wouldn't it just be a square?
How much?
Wouldn't it just be a square, it should be equal on all sides?
But the flowers, I told you, you better put a rectangle up.
Right, I know.
I didn't want you to put up no what? Square? We want a rectangular garden.
Okay, I mean,
Y'all hurry up and do that problem. Mr. Wilson, what'd you get? It's a simple problem, you all.
I mean, like, once you do all the math for you, you're gonna get X minus 80.
What'd you get? You got it? Whoa. Go too far. Get this back off here. Get that back off. How many? Y'all listen to me. How many of you in this room recognize my equation on board? Raise your hand if you recognize my equation. Mr. Farmer, you better. Gee. He almost went over his hand there, but he scratched his ear instead.
It's X.
You recognize my equation?
X plus 4.
Mr. Roberts?
40.
Yeah, y'all listen to Mr. Roberts. Y'all shut up and listen to him. Mr. Roberts, tell him again. Hell, it's a quadratic equation, you all. How many of you know how to do quadratic equations? Put your hand down because apparently you don't. Because hell, you'd already worked my problem if you did. I mean, what is that a quadratic shape like that's on the board?
A rectangle.
Oh my
Damn.
God.
Somebody get her something to drink, besides water. Get me something water, hell, I don't care, one of the two of us gotta have something to drink. It's shaped like how, Mr. Wilson?
Hairball.
No, it's not, it's what, like a frowny face. Shut up, it's a frowny face, damn it. Listen to me, and that frowny face has a what? Has a maximum point, right?
Yes.
You know what produces that maximum? You know how to get that maximum point? How you get it?
Find the values of.
Discriminant.
Mr. Flowers, then you don't think discriminate.
I would just grab it.
Hurry, come on, Robert, hurry.
Two. Come on, man.
Yeah, somebody finally got it. Negative B over 2A. Good Lord of mercy, you got the answer. Right, staring you down,
He
folks.
was talking about the points, the critical too.
Don't you see that? Do you not see that that's a what?
Parabola, upside down.
Is how much? So the width is 40, folks. The width is 40. So to make this the maximum, this is 40, the width. If this is 40 and this is 40, you know how much 40 plus 40 is?
80.
80. Do you know what 160 minus 80 is?
80.
Folks, you cannot make a rectangle with one side missing any other way that produces what? A maximum size garden.
I knew that.
Does that make sense? It makes sense?
Yep.
Of course it does. Makes all the sense in the world because we wound up with what? With a full quadratic equation, and y'all know how to do quadratic equations. You know they're shaped like this, and you know what? If they're shaped like this, there's a maximum point somewhere. You know what? There's an x value that makes it maximum. And we found that to be what? 40. So when x is 40, so if the x is 40 and 40, that would make this what? 80. Make it any other way, and I promise you, you won't get what? 3,200 square feet. You'll get less in a rectangle. Mr. Jackson, I saw you squint up your eyes. What happened?
I was thinking.
That's
We
dangerous.
got there.
For you.
I mean, folks, calculus does this for you. Calculus says derivative of A with respect to X is equal to. You make that equal to 0. That gives it to you right there. That's calculus. You didn't even do calculus to get the answer. How many of you have ever had a calculus course? Put your hand down because you had.
Aren't we meant to pre-calculus? I took,
You'd have worked my problem with calculus if you had. Somebody gave you what? A watered down course probably. Did they? Did you take calculus?
No.
No.
I took teaching.
Why would you pick
medicine
calculus?
back
Oh,
in
gee, I don't know.
I don't have that for my major.
That's a little bit of my strong point.
You don't need it for your major, you need it for your life.
You should have never said that.
I'm not gonna take the course, I don't
That
need
was
it.
the wrong thing to say. Somebody got to do the math.
Yeah, somebody has to do the math. Somebody has to do the math. I'm through. That's all I'm gonna say.